In this video, we're going to look at measures of center. So we have different ways that we look at where the center of the data is. And the most common way, the one that most people think of, is mean. And when we say mean, a lot of people think average. It is the most common type of center we look at. This is really being referred to as the arithmetic mean, which means you add up all the data and you divide by how many data values there are. It has a formula, and I wanted to point something out in this formula. This formula is using a symbol that we're going to see pop up on our formulas. That symbol is capital sigma, and what it represents in math is a sum. So they're adding something together. And that's true for any book. If you open any math book and you see that symbol, they're adding something together. What they're adding is the data values. Now notice they use x sub I to represent all the data values. I means that it could be anything from the first data value to the last data value. So if it's listed out, you'd be adding x sub 1 plus x sub 2 plus x sub 3, and you keep going until you get to the last data value. So this represents the last data value, this one the first. And since the last data value they labeled x sub n, that means there's n pieces of data, so they're dividing by n. We've also used n to represent our sample size. Now this symbol, the x with the bar over it, that is x bar, and it represents the arithmetic mean for a sample. Now let's just look at an example down here. So they ask us to find the mean for 20 students, and they gave us the exam scores for all 20. So if you go ahead and add that up, and I encourage you, take a second, grab your calculator, add them all together. I added them up and I got 1460, which when I divide by 20 gives me 73 exactly. So that is the mean. Most people are very comfortable with this. You know, they're used to the mean whenever you say average. I did want to make a couple important distinctions. So X bar is what we use for when we're talking about the sample. But when we're talking about a population, we use a different symbol. That's this symbol. That is mu. That's the Greek letter mu. And it represents the population mean. So it's like a U with the tail in front. So that's intentional. It's like a U with a little tail in front, like that. So in this example, if we're finding the mean scores for a class of 20 students, we're not talking about a sample. This would be the entire class. So it would be appropriate to label 73 as the mean for the population with mu. Now, another measure of center that most people are very familiar with, and we've even talked about already, is the median, being the middle value, which we introduced as the second quartile. It also represents the 50th percentile. So we already have used median prior to this. So here's when the median is useful. The median is a better measure when there's possible outliers, because it's resistant to outliers. It's not going to be affected in its value if there's an outlier. In other words, let's say one person scored 5 on their exam. That's not really going to affect the median. However, if you put that into the mean, that is going to affect the mean. It's going to really lower the exam scores because it's so far lower than the rest of the scores. So the median is what they call resistant to outliers. So in this example, we know we have 20 students. So let's find the middle here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. Count it again just to make sure. Yep. So 10 on one side, 10 on the other. So we're going to average these two. 72 plus 72 divided by 2 is just 72. Okay. So mean has special labels, but the median really doesn't. Often it's just capital M. They don't have a difference between sample versus population. That's because the mean is more frequently used. And the reason is kind of obvious. it uses all of the data in its calculation. And somehow that feels like it's a better average. But the median is important and it tells us a lot of information. The fact that the mean and the median in this particular example is so close. Oops, I said 72 and I wrote 2. How funny. The fact that their values are so close tells us something. It tells us that the way the data is spread out, how it kind of looks, means that it probably tends to be centered towards the middle. And therefore, most of the data is grouped up in the middle, and the mean and the median kind of group close together. Okay, so let's look at an example here. They ask us to find the median and the mean for this one. Let me zoom in a little bit. And okay, so we're gonna go ahead and average that out. Let me go ahead and add that together. Actually, wait here. I think I've done it. Yes, I have. Pause the video again, add them together, double check. I'm getting 943. And hold on. Okay, that's right. There's 40 pieces of data here. Okay. So 943 divided by 40 comes out to 23.6. And that would be the mean. Now, for this example, the mean, are we talking about a sample or a population? Might be worth kind of looking at. I don't think they really specify. Number of months living with AIDS after a new antibody kind of makes me feel like maybe this is a sample. They're testing a drug of some sort. Since they didn't tell me, I'm not going to label it, but I tend to think that X bar would be appropriate. Okay, now for the median. So since there's 40 pieces of data here, I want the first 20, and I believe I separated this actually directly in half. I think this is 20 pieces of data and this is 20 pieces of data, which means that this is the 20th data value and here is the 21st data value. And since they're identical, if I add them together and divide by 2, the median is going to be 24. All right. So because they're so close, that means that there's probably not really any outliers here. If they tend to be pretty far apart from each other, and that, of course, is really subjective with the problem when I say tend to be far apart, then we might be worried about an outlier and the median would be more appropriate. But since they're so close together and I don't really see any numbers that seem to be super far away from the rest of the numbers, it makes me kind of believe that the mean would probably be very appropriate for this since we don't have outliers. So we want to use the mean whenever possible. But if there are outliers, I'd be more inclined to use the median. All right, mode is the third type of center that most people are familiar with, and the mode is the most frequently occurring value. So going back to the same problem we had earlier for the 20 students, there happens to be definitely the most occurring value is 72. There's 5 scores of 72. So in this case, the mode is 72. Now that matches the median. And the advantage of the mode is that it kind of gives us another double check for worrying about outliers. All right. Or seeing if this piece of data happens to just match the rest of the information. But the real value of the mode is that we can use it when we're looking at qualitative data, which I say down here in this note. So it works best for qualitative data because there's no way to find a mean when you're talking about colors. Really, in that type of an example, you would have to say the most occurring color, it would be the mode, and therefore that would be the only measure of center we would have for that data. Okay, so sometimes the data is organized into a frequency table. And if that's the case, we're going to have to kind of guess a little bit about the data. So let me just kind of scroll down to this example and we'll talk about the formula. So in this example, we're given some data from a class again, and we're kind of given a rough breakdown of the score. So here, I think, okay, yeah, so this totals up to 19. So there's 19 total here. And all we know is that one person scored between 50 and 56.5. Nobody scored between 56.5 and 62.5. 4 people between 62.5, 68.5, and etc. Okay. Now, the problem is we don't know, like for these 4 people, I don't know what they actually scored. I don't know if like one of them got like a 63 and another got a 65 and another one got a 68. Like I have no clue what the actual raw data is. So we have to approximate the data. And the way we do that is using the midpoint of the interval. So that's what this is talking about up here in this formula. So F is the frequency of the interval, how many, are actually fall into the interval, and M is the midpoint of the interval. So the way we calculate the midpoint is we add together, and every book kind of does this a little bit differently, and every person kind of does a little differently. The most common is to add the first data value for the first 2 sets together. So to add 50 plus 56.5. Oops, and then divide by 2. So like average those 2 out. So that comes out to 53.25. So that would be the midpoint for the first interval here. So for the second interval, I would do 56.5. And then the next interval, which is 62.5. And then divide that by 2. And that comes out to 59.5. Oops, sorry. I said 2.5 and didn't write it down. 59.5. And then I'd add 62.5 plus 68.5. And that's going to give me, let's see, 66.5. 68.5 plus 74.5 divided by 2 comes out to 77.5. And then it's 83.5. And I encourage you, pause the video, double check that you're getting all of these values so that you're able to calculate that. Oops, did I write that wrong? 83.5. Oh, wait. I think I did. Yes. That is not 77.5. Just kidding. That's 71.5. The next one is 77.5. And then 83.5, 89.5, and then 95.5. All right. So for the last group here, I kind of assumed that the next number, if it continued, would have been 98.5. So we're assuming for this last number, I'm just going to write that down, that came from what the next interval would have been. It would have started at 98.5, and then we would have divided by 2. And the reason I know that is because you notice that these, the second number here is always the first number in the next interval. Okay, so there we go. Got all my midpoints. I'm going to go ahead and erase the extra numbers here just to kind of make it not so messy. And what we're going to do is we're going to multiply each midpoint by the frequency in that category. And then we're going to add them all together because that's what this symbol means. Sum them all together. Okay. So I'm going to add them all together. And then I'm going to divide by the total frequency for the whole thing. So I'm adding up all the frequencies, which I already know that's 19. I already figured that out. Okay. So I'm going to multiply 53.25 times 1. 59.5 times 0, which is just going to come out to 0. 66.5 times 4, 71.5 times 4, 77.5 times 2, 83.5 times 3, 89, let me clean that up, 89.5 times 4, and 95.5 times 1. So we're going to multiply all of those, add them together, and I'd pause the video, do that really quick. I'm getting 1460.25, which when I divide by 19, oops, 1460.25 divided by 19, that looks funny. That's going to give me 76 point, I guess you could say 76.986. I don't know. You can round that. That's fine. And we are going to label it X bar because it is kind of a sample. We're not really going to get to actually total the population because we're using the midpoint really to approximate. So they typically use X bar in that representation. Sometimes they call it the mean. It really does depend on who's labeling it. But I'll just go ahead and use X bar for this since we made an approximation.